This is the first of 3 videos in which we're going to look at examples of how to solve equations graphically and algebraically. This is our first example, and we're going to work with this equation right here. And we're going to solve it 2 different ways. And if we do it correctly, we should get the same answer both times. All right, first I'm going to go ahead and solve this equation graphically. Right? In class, you will either have graphs that you know how to graph really well, or you'll have the graphs given to you already. Right? This video is not about how to graph these equations. We're just going to be working with the graphs already. Right? So if you need help with how to graph them, we can work on that separately. But in this slide here, I have the graph of y is equal to x squared plus 12x plus 27. Right? And you'll see that that matches the left side of this equation. Y is equal to x squared plus 12x plus 27. That's already here. That's already graphed here. Okay? And what we're going to do is we're going to use this graph to solve this equation. Okay? And what I want you to do is I want you to think about what these points on the graph mean. For example, if I'm looking at this point right here, right, this point is -6, -9. Right? What does that mean? Right? Well, that means that when x is -6, the y value is -9. Or in other words, when x is -6, this x squared plus 12x plus 27 is equal to -9. When you input -6 here, this whole thing will be -9. Right? That's not what we want. We want this to be equal to -5. Let's look at another point. If I were to look at this point right here, this is the point -5, -8. Right? And what does that mean? Again, that's saying that when x is -5, the y value is -8. Or in other words, when x is -5, this x squared plus 12x plus 27 is going to be -8. That's not what we want either. We want x squared plus 12x plus 27 to be equal to -5. Right? And that is going to happen right here at this point. Right? This point is -4, -5. Right? And why is that significant for us? Right? Again, this is saying that when x is -4, the y value comes out to be -5. And our y value is equal to this, x squared plus 12x plus 27. So when x is -4, this x squared plus 12x plus 27 comes out to be -5. So we know that one of our answers is -4. Are there any other answers? There is. There's one other answer. And we can look right here. Right? This is the point -8, -5. And what that is saying is that when x is -8, the value of this, x squared plus 12x plus 27, comes out to be -5, right, which matches this. So that means this equation has 2 answers. If x is -4, this will be equal to -5, and if x is -8, this will be equal to -5. 2 answers. X equals -4, x is equal to -8. Right? And so the idea is, if you have a graph, you can really easily see when will this equation, or when will this parabola have a y value of -5? When will this expression, x squared plus 12x plus 27, equal -5, using the points on the graph. Right. Now, I'm going to work with that same equation, and we're going to solve this algebraically. And if we do it correctly, we should get the same answers that we did on the last screen. We should get x is equal to -8, x is equal to -4. Alright, so for this equation, I see that I have a quadratic equation, a second degree polynomial. I want to get one side equal to 0. So what I'm going to do is I'm going to add 5 to both sides. That's going to get me x squared plus 12x plus 32 is equal to 0. Right? Then this can be factored. This can be factored as x plus 8 times x plus 4 equals 0. Now using zero product property, I know that either x plus 8 has to be equal to 0,